Okay, today we're going to talk about slope-intercept form versus point-slope form. Okay, we've been working with slope-intercept form a lot. That's y equals, let me write this in nicer. Okay, y equals mx plus b, and just for a refresher, m is the slope and b is the y-intercept. So it's pretty easy to write an equation of a line in slope-intercept form if you're given the slope and given the y-intercept. It's just plug it in. Okay. Point-slope form. Let's see. It's y minus y1 equals m parentheses x minus x1. Okay. So that should be new to you, at least somewhat new. Okay, m is still the slope. Okay, but this y1 and this x1, they come from an ordered pair. Okay, or a point on the line. Okay, so in the situation where you're given a point and the slope, it actually makes a little more sense to just use point-slope form. Okay, now you can interchange between either one. You can make them all end up looking the same. You can change them all to standard form. You can change them all back to slope-intercept form. Okay, a lot of times when we end equations, we end up, or when we finish up an equation, we end up in the form of slope-intercept. Okay. Let's look at a problem, and I'm going to do it two different ways. I'm going to do it in using slope-intercept form, and then I'm going to also do it using point-slope form, just to demonstrate the difference between the two. Okay, so we have the slope of 1/2 and the ordered pair 5, 3. I'm going to start off, I'm going to use slope-intercept form. Okay. The point they gave us is not the y-intercept, so I can't just plug in the y value for b like I do if I'm given the y-intercept. If this was 0, 3, then I could just plug in 3 for b and go with it. Okay. What I can do is plug in the slope. Okay. 1/2 is my slope. I can plug that right into m. Okay. So I get y equals 1/2 x plus b. Lots of things I don't know. Okay. For a final equation, I need to still know b for sure. Well, I don't have b, but I do have an x and I do have a y. X and y. Okay, so I'm going to take the x value and plug it in where x is, and take the y value and plug that in where y is. Okay, so I end up with 3 equals 1/2 parentheses 5 plus b. And now I just need to solve for b. Okay, this gets a little sloppy. It's got a fraction in there. So 5 times 1/2 is 5/2. Okay, and then I need to subtract 5/2 from both sides. Okay, 5/2. What is that? 2.5. Yep. So 3 minus 2.5 is 1/2. So b is 1/2. So I can go back up now, and I can say that y equals, the slope is 1/2. Okay, this 1/2 comes from there, plus 1/2, because this 1/2 comes from there. Okay. Okay, let's look at that same problem, but we'll use point-slope form. So, slope is 1/2, point is 5, 3. And we said point-slope form was y minus y1 equals m parentheses x minus x1. Okay, we'll just plug in the things we know. We don't know y, but we know y1. So minus 3, okay, there's y1. equals the slope 1/2, x, we don't know x, but we know x1 is 5. Okay? Okay, we've got everything plugged in, now we just need to simplify. We can solve for y so that we can check to see if it is the same as what we got with slope-intercept form. So y minus 3 equals, let's distribute this 1/2. So 1/2 x minus minus 5/2. Okay? And now we want to add 3 to both sides to get rid of the -3 or the -3 on the y. So y equals 1/2 x, and then -5/2, which is the same as -2.5. So if you're at -2.5 and you add 3 to it, you're now at +1/2. And if you notice, we ended up with the same thing in a couple less steps. We didn't have to back substitute. Okay? So point slope form makes things pretty nice when you're given a point and the slope. Okay? So you can kind of go from their titles. Okay? They kind of tell you what things, if you're given these things, this is the form of the equation you should use to write the equation of a line. If you're given the slope and the y-intercept, then use slope-intercept form. If you're given the point and the slope, then use the point slope form.